Team, we're going to go ahead and look and see how a negative A value affects the dilation. So let's go ahead and play around. So in number 5, the graph shows a function h of x is equal to -1 being multiplied by x plus 3. I like to think of it as the opposite of x plus 3. So what we're going to do is we're going to choose several points on h of x and dilate each by, and then this is where you're going to have to listen carefully, multiplying by the x value of that particular point. So what we're going to be doing is we're going to be taking h of x and multiply it by the x value. So let's go ahead and look at some of these. I'm going to switch the order though. I always like to go x, y. So I am going to go ahead and put this over there. So x, let's go ahead and look at the point that should stay the same always. -3. So when x is equal to -3, the output is 0. So what I'm going to need to do is multiply them, and then this will give me my new value, the product of both of them. -3 times 0 is going to be 0. So my new coordinate is going to be -3, 0. Let's do this again. So let me look at this point, -2. The y value is currently -1. So I'm going to multiply these two together to get +2, thus giving me the new point, -2, 2. I'm going to graph it. This point is going to now be here. So you could kind of think like I've already used it. My next guy. Let's try the input of -1. Well, when the input is -1, the output is -2. The product of those is positive. So this is going to result in -1, 2. -1, 2. Let's keep on going. This was used. Let's go ahead and test out the y-intercept. 0 to the left and right, and then down -3. So what is the product of these two? Still going to be 0, leading me to a y-intercept of 0, 0. Also, notice how this y-intercept is also an x-intercept. I can go ahead one more time just to illustrate what's happening. I take a +1. The input causes it to be -4. 1 times -4 is -4. So this is going to be 1, -4. I go ahead and graph 1, -4. Oh, it's in the same spot. So the idea, and this is not going to be exactly, but it's going to look like so. So the idea is do the values you can and then predict based on the behavior. I know that there's going to be a vertex that is going to be a maximum, is going to be in between those 2 points. Okay. So we need to write our new function. Oh, we're going to call it j of x. Well, what is x times h of x? So j of x is going to be equal to x times -x minus 3. Now you might be wondering where I got that from. All I did was distribute the negative here. Now I'm going to clean it up a little bit. J of x is going to be equal to -x squared minus 3x. Notice how this is now a quadratic. Why? It's degree 2. Degree 2 means it's going to have 2 solutions. Remember, the solutions are the x-intercepts, which are the zeros. What are the zeros? All right, notice I can look at my graph. I'm going to go ahead and just ask myself 2 questions. 0 is equal to negative x plus 3, and when is 0 equal to x? This is case 1. This is case 2. Where did I get that from? Well, a quadratic. These things are being multiplied together. Let me look at j of x in factored form. And it's revealed that, hey, when is case 1 equal to 0? When is case 2 equal to 0? The reason why is they are x-intercepts. An x-intercept is always going to have a y value that is 0. So that's why I'm able to do this. Knowing the behavior, though, I could avoid some time and jump right away to it. Notice how x, when I solve this equation, is going to be positive 3. What number will make it 0? Here, it's still just 0. Notice 0 and positive 3.